Let me show you how Sidekik can help you write better Solidity code. So on the left, I have my editor. On the right, there's Sidekik. So let's first add some contract. Here I've added a boilerplate contract. Sidekik found it on the chain. It's looking at local hardhat. Okay, so it's showing me that I have one public function name, and the output type is string, which makes sense with our code. If we call it, works. Okay, so we know our code is good. If we change this value here, we should get an updated value. That's good. Okay, let's write a function to change the name. So function, call it set name. And it should be public. Okay, so all right, so we know that whatever stuff we wrote over here works, it shows up. That's good, but it doesn't do anything, doesn't take any inputs. Let's fix that. So this should take a string. Let's call it new name. And this should obviously be memory. Okay, cool. So we know our code is good. It takes a name. Let's put in some name here. Okay, it's the transaction ran, costs us some gas. And let's see the name. Oh, it hasn't changed. Well, we're gonna write the code for it. Let's say we're gonna say name is equal to new name. Okay, I don't see a problem with our logic. Let's check if this works. Set the name. Hey, okay. So far, we're able to write code to see the name and set the name, right? Can we do something else? Let's say, well, one thing is that we know that we shouldn't write a function which accepts a string. But, it's better practice to take bytes 32. So let's see if we can do that. Well, let's say this should take bytes 32 in new name, and this should be code. Okay, so we wrote this function. It takes bytes 32 to set the name. But now the problem is that we need to know bytes 32 or what we want to set to. So there's a helper function for that. We can type in string hello, and we can see that it's actually going to send the bytes for us. Let's see, set this. Okay, so that's good. Let's find a decimal. Let's say H 200, and this doesn't show up. Well, that's not public. Let's make it public. Okay, we can see that H shows up too. Okay, next let's add a mapping of address to values. Let's call it balances. Doesn't show up here. Oh, again, I didn't write public. Cool. So we know this code is good. Let's call it. Okay, so these are all of our wallets on Chainlink. That's the Chainlink. These are all of our wallets coming from hardhat. You can see there's no money, no balance in them. Let's write a function to set the balance. Yeah, don't forget public. Okay. Well, we have to figure out who we're setting the balance for. So, and what the balance should be. So let's take an amount and say balances send amount. Okay. So let's make it 100. Oh, cool. This wallet is still 0 because we're calling from F39. This guy should have 100. Okay, let's change our wallet. Let's change it to 9057 and set balance. Now we should see this is still 100. And so, okay, so we know that this code is working. We're able to set the balance, and whatever wallet we make a call from, it's setting the balance on that one. But there's one issue. We want the balance to increase, not just override. So that's a error here. Let's fix it. Let's do this. Okay, now, as per this logic, the balance should increase. Let's see. If I set the balance to 1 for this, it's 1. And now I set it to 2. This should be 3. Hey, it is 3. Perfect. That works. And I think we should rename this. It shouldn't be called set balance. It should be called add balance. Okay, cool. Let's see. Add a unit, add 5 units. Should give me 6 units. What if we want to add like 10 to the power 18, one ETH amount of units? Well, there's going to be a lot of zeros, but thankfully this will help us. So this is telling us, it's sending us 18 units with it, but I want to send 0.2, and then I want to add 0.3. Okay, see the balance? Ooh, I don't know what the number means. Okay, so we got 0.50. Well, there's some decimals in the end too. But there's one issue here, is that we're able to add balance, and we're not like charging anything. So maybe we should make this function payable. Payable. So we've made the function payable, and this should be message.value. All right, so add balance, we're taking amount. Let's go from wallet 1. We have a bunch of ether here. Let's send up 5 ether. And let's check balance. 5, okay. Oh, that's 5 number. We only said 5 away, so it only has 5. What we want to do is send 5 ETH. Okay, now it has enough. Cool. And let's send another 1. Now it should be 6. Okay. So our code to add balance is working. Let's write code to transfer balances. So we'll write function transfer. Okay. Okay, so our function is here. So what do we want? We want it to transfer the money from one account to the other account. Well, we want to transfer from our own account to another account. So let's just say this will be address to, we want to transfer. And we want a number. Okay. Cool. So we can see that our code is it's accepting input of a number, an address, and a number. Okay, so let's do the transfer. So let's say the balance is 2 note. Okay, cool. Okay, so let's start with our wallet. Check our balance, no money in it. Let's add some money. Okay, we got 1 ETH, or 10 to the power 18 units of number, whatever you want to call it. Let's transfer some to the second wallet. Let's transfer 0.1. Okay, so this will remove that much transfer. Okay, and let's check our balance for the new one. Hey, nice, it's got 0.1. Let's see an ETH. It's easier to see like that. 1, and we should be at 0.9. Oh no, we're not. We're still at 1. So we have a bug. Let's go back to the code. Well, it's because we didn't withdraw from our own balance. So it should be balances. This is that sender. Subtract from us the amount. Okay. Hope this logic is correct. Let's check. Start with 0. Let's add 1. We got 1. Let's send 0.9 to this guy. 0.1 to this guy. We should have 0.9. Yay! And this guy should have 0.1. Okay, this is correct. Let's send this guy 0.5 more. Okay, he's got 0.5. Should have 0.6. Okay, so there's a bug here. Yeah, we didn't have the plus. Okay, now let's try it. Let's see. This guy has 0. Let's give him some money. Transfer 0.5. There's 0.5 left, and this guy has 0.5. Let's give him another 0.2. Now it has 0.7, and the original should have 0.3. Okay, good. Let's send it. Let's send another 10. Let's see what happens now. Okay, so it seems like the VM blew up. Arithmetic operation underflow overflow. Okay, let's fix this. This should be nicer. So we should say require that the balances of not sufficient balance. Okay. Well, let's say nothing. Add 1 ETH. I got 1. Let's give this guy 10. Okay, so this is showing us, I think it's showing us that our required statement logic is correct. Transfers are correct. Amounts are correct. It's deducting the right amount and adding the right amount. Well, there's one other thing we should do is we should be able to show an event here, or fire an event whenever there's a transfer, so we don't have to keep checking this back and forth, who has what money, who got what. So let's add an event. And let's say, okay, what do we want to see in this event? We want to say from, to, and the amount. Okay, so here, submit transfer from is this guy, 2 is this guy, and this is the amount. All right, let's see if our logic is correct or not. Let's check the balances. Add 1, let's send this guy 0.1. Cool. So Sidekik's showing us that the transaction went through and this event was fired. 0.1 was transferred. One thing I actually noticing here is that the gas sent was 52,000 units. So what is that in USDC? It's almost 93 cents. And it's calculating that by looking at a 14 GUI price and 1272 of Ether. Okay. So what if I remove this event over here? What happens? Let's actually write another transfer function. Let's say another transfer. And this time we won't have this event. Well, let's see what happens. Okay. No money, add 1 ETH, add 1. Okay, let's see. This guy, send him 0.1. Let's another 0.1, another 0.1. Okay, so the gas seems to be 62 cents. And this one has no event. So let's see. Better. Oh yeah, this is a number. Should be ETH. Okay. Oh, look at that. Looks like that looks less. 59 cents versus 62 cents. Interesting. So removing the event is costing us, 3.5 cents. Interesting. I think I want the event. I'm going to keep the transfer function. It should go away now. Okay. Cool. So one change I'm going to make is that every time the contract's deployed, I'm going to start off our wallet with 1 ETH. So I'm just going to change the deploy script here, and I've added this. So it adds 1 ETH. And then if we make a change here, you should see that this guy has a balance of 1 to start off. Okay, cool. Now that we are happy with our transfer function, and we're happy with the gas, let's do a bunch of transfers. Let's give this guy 0.1, ETH. Okay, let's give this guy 0.1, let's give this guy 0.1. And we're seeing that every time it does that, it's costing us quite a bit of gas. So let's write a bulk function to do bulk transfers. Okay, so let's think about this for a second. What do we want to do? We want to take a group of addresses to this guy. So we're going to give him a group of addresses. It's an array. Choose. And we'll give each of them a different amount or same amount. Let's say amount like that. Let's make this a little bit wider. Okay. So, sorry. So now we are going to accept an array of 2s and an array of amounts. So it's going to be different amount for each person. Or we can just do like the same amount for everybody. I don't know. Doesn't matter to me. Okay, let's say we take a bunch of addresses and same amount. So this UI is going to allow us to add a bunch of addresses. Okay, this guy, this guy, this guy, this guy. Change this guy. And we want to give everybody, let's say 0.2, no, here, 500 GUI. Okay, you can see that number is going to go. Okay, so let's look at the balances. Oh, wait, nothing. We haven't run the code yet, so actually nothing should happen. So let's write it in here for. So we'll loop through all of these guys and fire the transfer in. I'm going to say, okay. Actually, let's take a look at what the payload is building. So we can see that the front end is going to send this array of 2 addresses, which is going to go here, and an amount. Okay, that's what we want to send. Let's do the transfer. Okay, cool, it worked. We can see that 3 transfer events were fired. All of them got 500 GUI. Go back up here, we check the balances, and they indeed have, all of them have 500 GUI. So that's good. And our original account should have less money. Yes, I can see money has disappeared from here. So bulk transfer is working. And we should see that the total gas use is now proportionally less than had we done 3 individual transactions. only 54,000 units, 96 cents. Another gas optimization I've heard about is that you shouldn't have memory. You can have call data if you're not changing the item here. Let's see, is that true? Let's see. If I change this to call data, does it cost us less in gas? So let's see. Well, the first request is more because it's instantiating the memory, but let's look at the second request to compare. 95 cents. I believe earlier it was 98 cents. Let me actually clone this here. So we'll have one with memory, and then like this, and we'll say this one is the second. Okay, cool. So we got 7099 and 996. Okay, we're gonna give everybody 500 GUI. Okay, 53,000. And this guy takes 54,000. Interesting. So 96 cents versus 95.9 cents. So it's very slight saving by using call data, but it is a saving. So I'm going to use it. Yeah, I'm going to use this one. I'm going to use this one. Cool. Should see one of these functions disappear. Okay. Let's remove all this data from here. It's using up all that screen space. So another thing we can store, let's store, is the last transaction date. Let's go up. Cool, 0. We should set this when transfer happens. So let's go here. So last transaction date equal to. Okay. Does it work? I don't know. Let's do a transfer. Let's do this transfer here. Okay. Ooh, stored something. Well, something happened. Now this is a timestamp, Unix timestamp, but luckily we have a function that will tell us what it is. Remember 11. Cool. Yeah, it works. So let's write a function to update this last transaction date manually, like overwriting it. So let's do that function update last transaction date. Okay, and this one, okay, this needs to first take an input here. Input would be, you would tell us what date, so let's say it's the new date. And by the way, we can see as we're typing code here, I'm saving it and it's showing up here, so we know that whatever we are writing in Solidity is functioning and working. So this should be last transaction date equal to new date. Okay, I think this logic is right. Let's see. So last transaction date right now is epoch time, and if I set it to, I want to set it to November 1st. So I need to know Unix timestamp for November 1st. Oh, luckily, I have this. Hey, cool. Okay, so this was, you can see here, we'll submit the actual timestamp we need to. Set it. Okay, see cost of some gas. Let's check this. Hey, it's correct. If you want to see it, so the chain actually has this value, but we are in the UI casting it so we can see it and it's easier to understand. Okay, let's make another improvement. This transaction dates should be set by transfers. We wrote this update function, but let's say only the owner can call this function. So let's import OpenZeppelin ownable, and we should see some stuff here from owner. We don't. I did not import it. I didn't inherit from it. So it's ownable. Okay. All right. So I see the owner here is F39. I can transfer ownership, renounce ownership. So these methods are coming in from OpenZeppelin ownable package. That's great. And now let's go here and say that this is only owner. Okay. So this is working, but if I change it to another wallet, it doesn't work. Perfect, it protects it. And if I was to transfer the ownership to this guy, oh, I have to first be the owner. I'm the owner. So if I was to now transfer the ownership to 7099, okay, then go become 7099, and now try it. Yes, it works. Okay, so we know that our function to update last transaction date is functioning as we want. It's protected using the only owner modifier. By the way, you can do a bunch of other things too with Sidekik. Like, let's say we want to add a contract which we are not coding, it already exists on the chain. So let's say I want to add the die contract. We want to fetch its ABI from Etherscan. Okay, so now we have die as well. Cool. See, is this working? Yeah, it's working. Check the symbol. Okay. Let's see our balance here. Do I have any die? Let's see. Oh, I have one die. Cool. I want more. So what should we do? Well, one thing is we can impersonate an account and get money from there. So let's go to die. So, contact address Etherscan. Okay, so the holders. Let's take this guy with a bunch of money. Let's take his address. Where do I copy it from? So to impersonate an address, just type it in and impersonate. Now you're this guy. You have a lot of ETH. Okay, now let's check our a lot of die. Here's the transfer function here. So transfer from this guy to this. How much? 1,000? Let's say 10. It's plenty. Okay, you can see there was some event probably built into the die contract. Fired, you can see that. And now if we check the balance of our wallet, it's 11. Okay. And by the way, you can also connect Sidekik to MetaMask like this. And now all transactions will go through MetaMask. So I wanted to check the name, change it to food bar, write it in. So sending up the right bytes value, set it, and now we'll go to MetaMask. I prefer not to use MetaMask when I'm developing because it slows me down, but it is there if you want.